In this video, I'll talk a bit about friends of a class or struct template. You can grant a class template function or function template friendship in a class template definition. Friends can also be complete specializations of class templates or function templates. Now, if a function template is a friend, then its specializations are automatically friends as well. I'll show you a couple of examples in this video. We'll start off with a toString function, the typical toString function in the entity class template. The syntax can get confusing, so we want to start off with a simple example using the toString function, and then we'll move on to a operator overloading example later on. I have a simple example with the entity class template with a type parameter of t, and then here we grant this toString function friendship. Now remember, this is a friend, so this is a global function, not a member function. And so we specify a formal parameter entity p, which is going to be a reference to this type, an entity, okay, and I'm passing t for the type argument, and that is going to be const as well. And then we're going to do entity.member to print out, okay, whatever the value of that member is. Member is in the private section, that is also of type t. In the public section, I have a simple constructor. I have member p of type t, and that is going to be used to initialize the member, and the body is going to be empty for the constructor. In main, I have a variable x which I initialize to 44, and then I have this entity1 which I construct, and I specify that to be of a type entity, and I specify int as the type argument. Okay, and I pass in x for the construction, and then I do toString entity1. So remember here, I'm not going to do entity1.toString. toString is not a member function, it is a friend function. Control F5 to build and run, and that should print out 44 just fine. Looking closely at this friend, the toString function, the formal parameter is going to depend on the same type parameter that the class does. So I'll just go and copy this right here. Control C to copy that. Okay, and what I'm going to do now is I'm going to separate out the declaration and the definition of this toString function. And of course, as soon as I paste it down here, it doesn't know what t is. T is undefined. Basically, we want this toString function to be a template. And I'll just copy that and paste that down here. Basically, we've granted friendship to this toString function template. If we build and run, that works fine. And with this, the compiler is going to generate a version of that toString function for every version of the class. And that, of course, is so that you can use the toString friend in this way, where you have the formal parameter of this type. The compiler will generate a version of the function that has the appropriate type for that formal parameter, okay, so that we can pass in that object. Now, what if you want to specialize this? Because if you pass in a pointer, let's say entity1 is of this type, so we do entity, and we pass in pointer to int for the type argument, and we pass in the address of x for the construction. Then we build and run, and we get some address. Okay, that is with this toString function right here. So in this next section, I'm going to use pointers as an obvious example again for specialization. But of course, this will depend on the situation. Maybe you want to specialize for a specific type, some user-defined type such as vector or something else. But okay, let's go and specialize this toString function now. This being a full specialization, I remove the type parameters, and then I'm going to specify the type right here, so pointer to int. Okay, that is what we want to specialize for. And then of course we want to dereference whatever this returns. So entity p.member, I want to dereference that. Basically what this means is if we pass in a pointer to an int as a type argument when we construct an entity, then we want this toString function specialization to also work with that object, and we want to print out the actual value as opposed to the address that we'll get with this right here. Another thing that I've seen quite a few times, and that is also important to mention here, is that you can specify a particular version of the template function as a friend. So let's go and look at that. I'll just copy that. Okay, so this is going to be the declaration of the template function toString. And then to avoid errors, what we want to do is we'll copy that. I'm doing a forward declaration of this entity class template because we're going to use that right here in the formal parameter of this toString function template. And then we have the actual class definition right here. And then in the friend specification, so we specify the friend that we want to have. We can now do an explicit specification. Now, if you remember from the previous videos, how do we do an explicit specification with a function? You have the function name. We do void toString. Now, of course, we specify this as being a friend, but we have void toString. Then we have the angle brackets, and then we provide the type. So we do pointer to int, and then here instead of t, we have pointer to int. Now, it should use the specialized version of the toString function, and if I control F5 to build and run, that works fine. But if I do something else now, okay, I do entity1, which is of type entity, and I pass an int for the type argument, and I specify x, and then again toString entity1, you can think for a second what's going to happen. If I build and run, we'll get an error. And that is because we cannot access a private member declared in that class entity with an integer type argument. Where does that happen? That happens right here. It will call this function. Because we are not passing in an address to something, okay, we are passing in x, which is a variable x, and we're specifying here integer. Okay, so not pointer to integer. And we have an explicit friend specification here of pointer to int. And so this version of the toString function template will not have access to the private members of the entity class, because we are specifying this version here explicitly to be a friend of the template class. So in this way, you can explicitly specify which version of the function you want to make a friend or grant friendship to. But as you can see, it does lead to problems. So how you can avoid that is you can remove the specification right here. So leave that empty. And then we specify t. So t now depends on that type here, the type parameter. And if we build and run now, this will work fine. It will use the appropriate toString function. The compiler will instantiate that entity class template, and it will also instantiate the appropriate toString template function. And if I change the construction of entity1 and I pass in pointer to int for the type argument again, and the address of x, build and run that. And that works fine, we get 44. Now of course you can do some printouts to make sure you get the appropriate function. Something like that, and as you can see we get from toString specialization, it prints out 44. So that works fine. As I mentioned in previous lectures, instead of doing a toString function, what you can do is you can overload the stream insertion operator instead. And this is where the syntax can get a bit confusing with the friend specification in the entity class template. So let's just look at this as an example. Okay, at this point we have the insertion operator declared as a template function. This version right here is going to be the general template. So let's go and create a specialized version. We'll just go back to the entity class template definition. And actually I'll copy this up here. Paste that in here. Now I want you to pay attention to the syntax, so we specify this right here as a friend. This is the insertion operator. And then we have to do the opening and closing angle brackets. This is going to return a reference to the output stream. We've seen this before. The first formal parameter is going to be a reference to an output stream because we want to pass in a cout for that, which is an output stream. Then the second formal parameter is going to be entity parameter, which is going to be a reference to an entity constant. And we pass in t for that, for the type argument. I'll scroll down to main. Okay, so when we compile this, the compiler is going to generate an appropriate overloaded operator based on what we have specified right here, and based on the type that is passed in the second formal parameter. Control F5 to build and run. And so it prints out fine, it prints out 44 twice. Now of course we can copy this line and Okay, as I mentioned, you can add some printouts just to make sure that you're getting what you expect from those functions, and build and run, and you can see what we get. Once more, if I change the construction of entity1 to an entity with an integer type argument and I pass in x for the construction, and I build and run, this will also work fine. We get 44 printed out each time. As I mentioned, you can add additional printouts, so in the generalized versions of the overloaded stream insertion operator, in this case that is also a template, and the toString function, okay, right here, you can also go and add printouts if you want. Okay, you get the idea with this. I wanted to show you a couple of simple examples, so I hope you found this useful.